in this episode how to find a derivative by a limit process. Coming up, back into action. Hey guys, today I will show you how to find the derivative by using the limit process or the definition of the derivative. Now, this is the formal definition of the derivative using the limit. So it's the limit of f of x plus delta x minus f of x over delta x, where delta x goes to 0 or tends to 0. Sometimes instead of delta x you might see h, it's precisely the same, and f prime of x basically stands for the derivative. Also, it could be written in the way of dy over dx. It's precisely the same thing. Now, suppose you are given f of x equals negative 4x squared plus 7. So we're going to use this definition to find the derivative of f of x. So in the next line, f prime of x equals, you want to take this limit where delta x goes to 0, approaches to 0, fraction. So your bottom part delta x stays the same, so you want to rewrite it as this. Now let's form top. So f of x plus delta x. So what does that mean? That means that instead of x in your formula, in your equation that you are given, so basically you are given, this is your equation, this is your function. Instead of x, everywhere x appears in your formula, you are going to insert, you are going to plug in, you are going to put in the expression x plus delta x. Everywhere x appears. So since we have negative 4, so you have to keep it in front of your term, so negative 4. And instead of x, I'm going to write this whole expression, x plus delta x, in place of x. So x plus delta x. And since we have square, you have to keep it. And since we don't have any more terms, but you have this 7, this constant sticks out, so you have to keep this constant. So plus 7. And we are not done with top, so we need to subtract, we need to take off the f of x as is, the same function, the same equation. So I would suggest you to draw the parentheses, since it's always negative, and whatever you have, your f expression, when you distribute, when you open up the parentheses, the sign in front of your terms have to be switched, have to be flipped. So draw the parentheses to be safe. It's better to be safe than sorry. So, and you write your f of x as this. So you would write negative 4x squared plus 7. So notice that there is negative, as I said before, in front, since this negative means that negative from your formula, from your limit, from the definition of the derivative. And this negative, so basically comes from your function, your equation. Alright, we're done with that substituting part, but we're not done with the derivative. So we need to take the limit. So taking the limit is completely another story, and that's coming up. But at this point, use your basic algebra skills, simplify it down, and let's see if we can take the limit. So the next line, limit delta x tends to 0, approaches to 0. Write down bottom as this, delta x, so simplify within top. So open up the parentheses, and since you have a binomial squared, open it up. So you could simply use the formula a plus b squared, or you could simply take this binomial and multiply it by itself and FOIL it out, distribute it out. So negative 4 we keep, it becomes x squared plus 2 twice, so you have two like terms, x and delta x squared, plus this 7 And I'm going to open up the parentheses over here by switching the signs out front. So it becomes positive 4x squared and negative 7. Something might cancel, and at this point it will. So let's just check to see if anything can be cancelled. So 7 and negative 7. And we can open up the parentheses over here. So keep simplifying as much as you can. Delta x goes to 0. Open up the parentheses. Since you have this negative 4 in front, so this negative 4 needs to be distributed to all 3 terms inside. So apply this negative 4 by multiplying it to all terms. So negative 4x squared minus, notice that the sign has to be switched, negative 8x times delta x, negative 4 delta x squared, and plus 4x squared left over from the terms. Now check to see if something cancels out. So since we have negative 4x squared and positive 4x squared, we could simply ignore these 2 terms. Things getting better, you see, with the time. So next line, keep moving. Limit. Delta x goes to 0. And what's left over? So you would simply have negative 8x times delta x and negative 4 delta x squared. So all quadratic terms for x squared go away, drops out, disappeared, so over delta x. And again, look at your top. So since both terms involve this delta x, that can be basically pulled out, taken out and pulled out in front of the parentheses. Keep limit, carry it down, delta x tends towards 0. So let's pull out delta x in front. You have delta x1 on bottom. So what's left over? What goes inside of your parentheses? So negative 8x and negative 4 delta x. Now, at this point, since your delta x shows up on top and bottom, cancel it out. Alright, so it becomes, keep limit, and you would be left with, so no fractions, we got rid of this, finally, negative 8x minus 4 delta x. Now we're ready at this point to take the limit. We're ready. So since your delta x, this term, goes to 0, it tends towards 0. So this term completely goes to 0. So we could simply ignore this term at this point. And your limit of negative 8x is just simply negative 8x. That basically was expected, as you probably know the shortcuts, the derivative rules. So this is your final answer after this whole algebra work. Yeah, I know it looks shocking, but anyway, the great news that there are shortcuts. By using those, you would potentially avoid a bunch of algebra work involved in here. And that's another story that's coming up. But that's what it is. Alright, so this is your final answer. This is your negative 8x. This is your derivative for that function using by the limit process. I hope it was helpful. So thanks for watching and train your brain. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss out my new